So since we have now seen the types of automated manufacturing system, we're now going to see what are the elements of the automated system. An automated system consists of three basic elements, and the relationship between these elements is depicted here. So it has power to accomplish the process and operate the system, and we can see that there are three arrows, which means that each of the components or elements of automated system basically needs power. So program instructions feed to the control system, and so the program of instructions will direct the process, and the control system executes the instruction and drive the process. And we can see that here, for control between control system and the process itself, it has a two-way directions. So that means the control system has feedback from the process as well as instructions to the process. So it is important to see that for the automated system to be called automated, you need the feedback in place for the control system, and the process itself is somehow powered externally and is not basically manually done. Okay, so an automated system is used to operate some process, and power is obviously required to drive the process as well as controls. The main source is basically electrical because it is widely available at moderate cost, can be readily converted to alternative energy form, can be stored in long life batteries in locations where electricity is not readily available, and in low level it can be used for controls. So in production, the term process refers to operation conducted on a work unit, for example in electrodischarge machining, which is a controlled metal removal process that is used to remove metal by means of electric spark erosion. Electrical power is used to drive the servo motor for tool feed as well as providing the spark to erode the workpiece. In forging process, for example, mechanical power is mainly used to deform the metal work part by opposing dies. Work parts are often heated in advance for deformation, so the thermal power is also required. Another example of the use of thermal energy is sand casting process, in which the metal is melted before pouring them into mold cavity, where solidification occurs. In each of these processes, the power required is often converted from electricity. In addition to manufacturing process itself, power is also required for material handling, such as loading and unloading, as well as transport between workstations. So beyond the needs for power for processes, additional power is also required for automation. If we take a look at the machining processes that utilizes a lead screw mechanism to guide the machining table, power is needed for the controller unit to read instructions, make control calculations, and execute instructions at the actuator. So you need low power or low voltage control signal, and also amplified voltage control signal to drive the actuators. Operating the CNC machines, for example, require power to acquire data and maintain record keeping, as well as control the machine. Okay. Actions that are performed by automated process is typically we call a program of instructions, which is basically refers to the processing steps in a work cycle of production of producing a product. So a new part is basically completed during each work cycle, and this particular processing steps for the work cycle are specified in work cycle programs. So in the simplest automated process, the work cycle consists of simply one step, which is to maintain a single process parameter. For example, if we want to maintain the temperature in a furnace, the programming simply involves setting the temperature dial on the furnace. Okay, in a more complicated system, this involve multiple steps that are repeated with no deviation from one cycle to the next. So a typical sequence of steps is firstly load the part into the production machine, second perform the process, and third unload the part. So during each step there are one or more activities that involve changes in one or more process parameters. So process parameters is basically refers to input of the process such as temperature setting, coordinate axis value in position and system, whether valve is open or closed in a fluid flow system, or motor on and off. Okay, so process parameters or the inputs are distinguished from the process variables. So process variables are referred to the outputs of the process. For example, the actual temperature of the furnace, the actual position of the axis, the actual flow rate of the fluid in the pipe, and the rotational speed of the motor. So changes in process parameter values or inputs can be continuous, which means like there are gradual changes during the processing step, or discrete, which is stepwise changes, for example, on and off. Okay. So many production operation consists of multiple steps, sometimes more complicated than what I've been saying. So each manufacturing processes basically may be controlled by hardware components such as limit switches, timers, cams, and relays. Okay, but although it is quite adequate in performing sequencing operation, the disadvantages of using these mechanical or hardware components is that they often require considerable time to design and fabricate, and even making minor changes in the program was difficult and time consuming, and the program was in a physical form and that was not readily compatible with computer data processing and communication. So we typically use modern controllers to deal with that, as we will see in the next part of the elements of the automated system.